nearly $3 billion, the sum the Xi Jinping government spent on a desert highway stretching over 500 kilometers. It cuts through the Taklamakan Desert, the Sea of Death. One can notice how a single night of wind shifts dunes enough to bury an entire convoy. But this is just the beginning. Tens of thousands of workers mobilized to tame the landscape. At first glance, the sand seems calm, but in reality, the heat reaches 70 degrees Celsius. Blinding dust storms limit visibility. Even a small mistake could see the entire road swallowed by the dunes. How was this steel miracle achieved? The environment fights back constantly. Engineers applied specific secrets to carve the path. It is visible how the highway endures. The route remains open for transit. 70 degrees Celsius is the temperature the surface reaches in the heart of Xinjiang. Why build infrastructure here when crossing once meant walking for weeks or even months? The environment is one of the harshest on Earth, with sandstorms capable of swallowing entire convoys in minutes. But beneath this sea of sand lies a hidden treasure of enormous reserves of oil, natural gas, coal, and rare earth minerals. Beijing had to attempt the unthinkable to connect the region. One can notice the Taklamakan Desert lying between two towering mountain ranges like an endless ocean. This area was historically an impossible blind spot for engineering due to the shifting terrain. Therefore, the Luntai-Minfeng Expressway, stretching more than 522 kilometers, was launched. Construction began in 2017 and finished in 2021, becoming China's first and longest desert crossing highway. At first glance, the route looks simple, but in reality, the work started from scratch in the middle of a sandy desert. But this is just the beginning. How do you build a highway across a desert that never stops moving? It began with high-resolution satellite imagery and ground-penetrating radar scanning the depths. It is visible how survey teams took thousands of wind measurements to map the shifting dunes. Engineers located pockets of stable ground to ensure structural safety. The survey teams complete the mapping for the next stage. 30 meters is the depth reached by boreholes, drilled in the shifting sands of the Taklamakan. Survey teams lived deep in this arid expanse for months to study the layers hidden beneath the dunes. Why is such exhaustive subsurface analysis necessary? The desert surface looks uniform to the naked eye, but the data ensures the foundation will hold against the unstable terrain. But this is just the beginning. Every route marker was staked strictly by hand. At first glance, placing a stake seems like a simple task. But in reality, engineers logged each coordinate with centimeter-level precision. The highway had to avoid dangerous wind corridors where sandstorms could bury an entire road overnight. One can notice how the route weaves to stay close to the oil and gas fields spread across the Tarim Basin. This was the first step in turning what was once a blank white void on China's map into a black ribbon of pavement. The survey work ends quietly here. 1,000 hectares of shifting dunes were tamed before a single drop of asphalt touched the ground. Hundreds of local farmers from oasis villages gathered to anchor the desert floor, earning between $80 and $100 a month. Their humble income kept families afloat, but their mission involved driving bundles of straw, twigs, and thin bamboo deep into the sand. But this is just the beginning. Workers formed a vast checkerboard pattern across the landscape. Why start a modern highway project with fragile bundles of dry grass? It would seem logical to immediately deploy heavy machinery to clear the path. But without this primitive barrier, the wind would bury the construction site faster than engineers could pour concrete. At first glance, placing sticks in the sand seems like a futile effort against nature. But in reality, it determined the fate of the entire highway. Each square measured exactly 1 meter by 1 meter, laid diagonally at 45 degrees to deflect the wind. Teams of a dozen men and women worked under a sun that pushed air temperatures above 60 degrees Celsius. Heat severe enough to bend metal beat down on workers who wrapped their faces in cloth and soaked their hats in water. They toiled in silence against the relentless gusts. It does not end at this stage. One can notice how the sand begins to crust and harden inside the traps. Wind velocity near the ground dropped by 40% within months. Heavy trucks could finally cross the terrain without sinking into the drifts. The grids created new zones where native plants found a foothold, protecting nearby villages. From this quiet labor rose the first layer of engineering. Hundreds of bulldozers roared to life to reshape the stabilized terrain by cutting down high ridges. They redistributed the material into lower areas to create a balanced surface capable of supporting heavy machinery. Surveyors monitored elevation and slope with strict precision to ensure uniformity over miles of open desert. Conveyor systems pushed excess sand away while compactors gently pressed the top layer. Everything only gets more complicated. Engineers discovered that injecting water was the key to binding the loose grains. It is visible how long sprinkler arms and underground pipes spray controlled amounts of groundwater across the site. Moisture penetrated several inches deep, creating a denser and more cohesive layer. This prepared the ground for the next phase of heavy compaction. Heavy rollers moved in to remove air pockets and lock the particles in place once the dampness reached the correct level. The constant rumble of steel drums echoed across the desert as each pass turned soft sand into a firm base. By the time the surface dried under the sun, it was hard enough to carry cranes, mixers, and supply trucks. Transition to the next level. A solid foundation required more than just compacted sand. Dump trucks poured out loads of reddish earth, which bulldozers leveled across the area to add weight. This layer strengthened the surface, preventing it from shifting under intense heat or vibration. Beneath the highway, engineers drove sand compaction piles and mixed cement directly into the soil. Dense vertical columns formed deep underground to act like roots. And this is not the limit. The camera glides along the route where geogrid mats made of strong synthetic nets were laid in looser areas. Convoys of trucks arrived shortly after to pour crushed stone and graded gravel. Bulldozers spread the mix into layers 20 to 30 centimeters thick to ensure maximum load distribution. Vibratory rollers pressed the material into a solid platform, locking the subgrade together. The pale gray surface stretched like a giant runway through the dunes. The roadbed now waited for its final black asphalt skin. 170 degrees Celsius is the scorching temperature reached by the mixture of stone, sand, and polymer-modified bitumen inside the portable asphalt plants roaring at the edge of the desert. Why maintain such intense heat in an environment that is already blistering? It would seem the ambient temperature of the dunes is high enough to work with the material, but without this precise thermal threshold, the asphalt would fail to bond correctly, rendering the road useless against the harsh climate. Insulated tankers deliver the hot mix non-stop to the paving machines waiting on the site, resembling a coordinated military operation. Each paver spreads the glowing asphalt in layers about 6 centimeters thick, creating a steaming path through the sand. One can notice how the heavy steel rollers follow close behind, compressing the material before it loses its critical heat. But this is just the beginning. The first passes utilize heavy steel drums for primary compression to establish the road's core density. At first glance, the rolling process appears to be a simple mechanical routine, but in reality, thermal sensors on each paver track the surface temperature in real time to prevent failure. If the asphalt drops below 140 degrees Celsius, rolling stops immediately because working on cooler material would inevitably lead to cracks. The final passes switch to rubber tire rollers, which knead the surface to seal tiny air gaps and create a smoother texture. Supervisors check flatness with laser beams, allowing no more than 3 millimeters of deviation per meter of the road. As the desert wind cools the surface, the asphalt hardens into a flawless black sheet, tough enough to withstand temperature swings from -25 to +70 degrees Celsius. To finish the surface, Workers spray a protective seal coat, giving the highway its signature deep shine and locking out moisture. By dusk, the newly paved road gleams under the sinking sun like a dark, mirror-like ribbon stretching across the golden sea of sand. What had once been an empty wasteland now reflects the light of progress, born from heat, steel, and human endurance. So after 4 grueling years of construction, the 4-lane highway cutting across the largest desert in China finally stood complete. This project not only connected the far ends of the region, but also showcased an engineering achievement so remarkable that it impressed even seasoned engineers from the United States. It gets more complex further on. A project on an even grander scale began to take shape across the same unforgiving sands of the Taklamakan. China commenced constructing an elevated railway, a steel ribbon suspended above the desert, defying heat, wind, and time itself. The Hotan-Rokiang Railway stretches 825 kilometers, forming a crucial part of the larger Taklamakan Desert Loop Railway, which spans more than 2,712 kilometers. Construction began along the southern rim of the desert and was completed in June 2022, making it the longest desert crossing railway in the world. More than 65% of the line, totaling over 500 kilometers, runs on elevated concrete viaducts supported by more than 11,000 pillars. This design allows desert winds to pass freely underneath the tracks, preventing drifting sand from burying the line. The initial preparation involves stabilizing the soil and sand foundation, mirroring the techniques used for the highway before the heavy work begins. Once the ground base is fully stabilized, workers start erecting the bridge pillars by drilling through dozens of feet of loose sand until reaching the solid gravel or compact soil beneath. Reinforced concrete pile drivers operate day and night using steel casing pipes and bentonite slurry to keep the boreholes from collapsing. One can notice how the equipment gradually lowers the steel cages with millimeter precision into the depths. The process is only gaining momentum. Concrete is poured from the bottom up through tremie pipes to prevent air pockets, while the cages are positioned with absolute accuracy. Because daytime and nighttime temperatures differ by more than 130 degrees Fahrenheit, construction crews work mostly at night, when the wind is calm and the thermal shifts are less extreme. Even the slightest misalignment could cause the pile to tilt or lose stability in such a volatile environment. Thanks to these steel and concrete piles, the railway's foundations seem to grow roots deep into the desert floor. On top of those foundations, 11,000 bridge piers begin to rise, row after row, forming a vast concrete forest stretching toward the horizon. Each pier stands between 16 and 50 feet tall, cast using slip-form molds, reinforced with galvanized steel and salt-resistant additives. The short, uniform spans between piers are designed to minimize the effects of wind and extreme temperature changes on the structure. Thousands of pre-stressed concrete box girders were lifted into place using heavy crawler cranes or self-launching gantries. Each girder is over 100 feet long and weighs several hundred tons, transported on specialized flatbed rail cars and hoisted one by one onto the piers. Engineers align the girders with laser precision, keeping tolerances within just a few millimeters. Once the spans are secured, crews pour the bridge deck slabs or install precast concrete panels, forming a smooth surface for the tracks. Every span is spaced to allow wind to sweep freely beneath, carrying drifting sand away so it can never bury the line. From above, the railway appears like a silver ribbon cutting across an ocean of gold, standing as a living monument to human ingenuity. And this is not the limit. Next, concrete blocks known as sleepers are placed evenly along the track bed to hold the steel rails in position. Workers align each sleeper precisely, then use a lifting frame to lower the rails onto them to distribute the weight of passing trains. Once fixed and fastened, they keep the track straight and stable, preventing it from bending or shifting under heavy loads. After the sleepers are secured, crews begin laying the steel rails on top, with each rail stretching more than 260 feet long. Specialized cranes lift them into place, carefully aligning them along the center line. Workers adjust every joint and gap to allow smooth expansion under heat, then tighten the fastening clips that lock the rails onto the concrete base. It took 11 months of continuous work to complete the hundreds of miles of track stretching across the desert. When the final bridge span was completed, the entire line entered the rigorous testing phase. Engineering trains ran up and down the route to measure settlement, vibration, rail temperature, and wind-induced sway. The bridges were load tested with trains weighing thousands of tons to ensure structural integrity. Results showed elevation deviations of only a few millimeters, even after hundreds of test runs. Thanks to the elevated design and natural airflow beneath the viaducts, no sand accumulated on the tracks during the trials. All operational data flowed to the control center through IoT sensors and solar-powered cameras that monitored every section in real time. After 6 months of rigorous testing, the Hotan-Rokyang Railway officially opened, completing the 1,685-mile loop that circles the Taklamakan Desert. One continuous line of asphalt now circles the Taklamakan Desert. At first glance, the shifting sands seem unconquerable, but the infrastructure successfully cuts through China's largest desert. One can notice the stability of the completed road. The massive building process reaches its finish.